Okay, so 3.6 deals with kind of the FOIL method, which I actually have some issues with, but meaning that I don't think it's the best sort of rubric to learn this, but we'll kind of go with it for now. It's not really such a big deal in this class, but as you get into 138 and 140, FOIL can actually kind of lead you astray. So I'm not actually going to explicitly follow FOIL. I'm going to show you my way of kind of looking at it, which is very similar, but works for larger polynomials. So if we look at this, the key thing to recognize here, now the majority of the problems you have something like this in parentheses times something else in parentheses. So the key thing here is to recognize that this squared means that you're dealing with the problem 4m plus 5n times itself. So you're doing that twice. Alright, so it's this entire term that's squared, and again, squared implies repeated multiplication. So you're multiplying this stuff in parentheses by itself. So now it looks like more like the other problems from this section. So again, the way I like to look at this is I start with the first term in my first set of parentheses and multiply it by everything in the second set. So if we do that, we've got 4m times 4m, and again, we start by looking at the coefficients out in front. So 4 times 4 is 16. And then we have m times m, which is m squared. And then we'll do 4m times 5n. So we've got 4 times 5. And again, everything's positive, so we know these are all going to be plus signs. So we've got plus 20, so that's 4 times 5. And then m times n, well, since it's not the same variable, we just write m times n there, okay? And now, since I've multiplied everything in this second set by my first term here, I can now move on to the second term in the first set of parentheses. And I'm going to multiply that by everything in my second set here. So I've got 5n times 4n, and then 5n times 5n. So 5n times 4m is 5 times 4, which again is 20. And then m times n, which is just mn. And then we've got 5n times 5n, so 5 times 5 is 25. And then n times n is n squared. Okay? And then from here, we can do a little bit of simplification. Because right here in the middle, we have two terms with both an m and an n in it, which means that they're like terms. So like terms can have more than one variable, but that requirement that they have the same exponent and they must be the same variables is true. However, this could have been written in a different order, n, m, and you still can combine them because multiplication is commutative. So you can rewrite this nm as mn. So watch out for that when you're doing your problems. So if we look at this, we can't do anything with the 16m squared, so that's going to stay the way it is. So if we add 20mn to 20 more mn, again we're focusing just on the coefficients out in front, that gives us 40 mn, and then we'll tack on the 25n squared at the end. Please let me know if you have any questions.